Assalamualaikum warahmatullahi wabarakatuh. I'm going to present. We are going to present our final year design project, which is the production of gluconic acid from oil palm polymers. So we are from Group TK16. Our project manager is Mr. Tushan Anak Laki Nabil. My name is Aziz bin Salim. Our group member is Muhammad Hanif bin Zakaria, Nur Afidah bin Tiap Samah, and Nur Faikah bin Syaful Amrat. So, for the introduction, the gluconic acid is a mild organic acid derived from glucose. It is a white odorless crystalline powder which imparts a refreshing sour taste. In aqueous solution, it will form a gluconic ion. For the physical properties of gluconic acid, it is a white odorless crystalline powder. It is a non-corrosive, non-volatile, non-toxic, and also a mild organic acid. The melting point of gluconic acid is around 121 degrees Celsius, and the boiling point of gluconic acid is higher than 417 degrees Celsius. So the product usage of gluconic acid is as a hand sanitizer, which is act as an antimicrobial agent. It is an additive in cements and paper industry, and also used in textile. So the reason we choose gluconic acid is we want to use it as an antimicrobial agent in the hand sanitizer. So the raw material for the production of gluconic acid is oil palm frond. So there are several parts of oil palm which we need to consider, which is the OPF, empty fruit punch, and the kernel shell. So the OPF was chosen because the resource availability is around at 45 million tons, where the EFB and kernel is only 9 million tons and 4 million tons respectively. The resource cost of the OPF is around 0.62 cents per kilogram. For the EFB is around 40 cents, and kernel is around 45 cents per kilogram. So for the process design level 1, this is our process structure. The raw material of this process is the air, the ammonia as the nitrogen source, the sulfuric acid for the acid pretreatment, water, cellulose enzyme, asparagine niger SP, and the oil palm frond. And for the product that we use, for the product that was produced by this process, the main product is the gluconic acid, and the waste material is the black liquor, water, the wastewater, and the side product is the biomass. And also we produce carbon dioxide as our waste from this process. So for the acid pretreatment, the lignocellulose, which is part of the OPF, will be treated with sulfuric acid, which is only 4% concentration, and we produce lignocellulose, black liquor, and lignin. We produce cellulose, lignin, and black liquor. So the cellulose from the acid pretreatment that we obtain will undergo the enzymatic hydrolysis. So the cellulose will react with water with help of cellulose enzyme. It will produce glucose. And for the main reaction is the fermentation process, where the glucose plus oxygen and ammonia will be fermented, which will produce biomass, gluconic acid, carbon dioxide, and water.
OPF consists of several compositions such as lignin, hemicellulose, and also cellulose. OPF will undergo the pre-treatment process to separate the composition to obtain the cellulose. Cellulose, water, cellulose enzyme will react each other in the reactor to produce glucose. As the glucose was obtained, it will feed into the seed fermenter with the bacteria A. niger. Oxygen needed for growth as the bacteria is an aerobic bacteria. Next, it will feed into the main fermenter to produce our desired product, which is gluconic acid, and also obtain the byproduct. Then, it will undergo the multiple suppression process, which is first one is filtration, crystallization, centrifugation, and finally the dry. Desired product, gluconic acid, is obtained in the solid phase at the end of this process. And Mass balance and energy balance for every unit operation was conducted. This slide shows the mass balance and energy balance for the seed fermenter. Based on the table, the mass flow rate for input and output stream in the seed fermenter is balanced with the total of 6,437.68 kg per hour. The reaction in the seed fermenter is exothermic since the value of Q is negative 1.114908 kilowatt. Reaction next is mass balance and energy balance for main fermenter. Based on the table, the flow rate of input and output stream of the main fermenter is balanced with the value of 18,122.54 kg per hour. The equipment undergo exothermic reaction as the value of Q is negative 1.6490 kilowatt. The graph shows the economic potential curve for level 2, level 3 and level 4. The economic potential included the cost of raw materials, reactor and also separation units. At the conversion of 80%, the value of the economic potential is ideal for the process. Next, both of the graphs shows the graph between the temperature and also conversion in the seed fermenter and main fermenter. As we can see, the process is the adiabatic process. The relationship between the temperature and conversion is, as the temperature increases, the conversion is also increases based on the temperature. The reaction is exothermic reaction.
Next is the PFD. This is the PFD before heat integration. So this is our first unit, which is the OPF. The OPF will be milk, and then will be sent to the reactor 1 for the acid treatment, and then we will transfer to the reactor 2. This is the reactor 2, which will undergo the enzymatic hydrolysis process, and then the glucose will be transferred to the glucose storage tank, and then the glucose storage tank will be supplied for the seed fermenter, and then the main fermenter. So this is the separation unit, which is the rotary filter, the centrifuge, the evaporator, and the dryer. And the final product is the gluconic acid. And then the side product is the calcium sulfate, and our waste is the biomass, the black liquor, and the sulfuric acid, and the excess sulfuric acid. And for the heat integration using the problem table method, the summary of heat integration is the minimum required heat for hot utility is at 174.27 kilowatt, and the minimum required heat for cold utility is 112.3 kilowatt. The change of the minimum change, the delta T min is 20 degrees Celsius. The pinch temperature is 35 degrees Celsius. The pinch temperature for the hot stream is 45 degrees Celsius, and the pinch temperature for cold stream is 25 degrees Celsius. For the total energy recovery, before the process is around 459.6 kilowatt, and after heat integration is 229.8 kilowatt. So the total energy recovery is at 50%. So this is our PFD after heat integration. What you can see, the cold stream and the hot stream.
Piping and instrumentation diagram for our design project, which titled Gluconic Acid from Oil Palm Biomass. We are using Aspergillus niger as our bacteria in order to produce high yield of gluconic acid. The example of controller that have been used in our design project is anti-foaming controller, pH controller, temperature controller, flow controller, and level controller. The objective of this controller can be discussed in the next slide. Instrumentation of control summary for the first equipment, which is seed fermenter SF101. The type of control that we use is a temperature controller, which is to control the temperature of process fluid at a desired temperature. And then dissolved oxygen controller, it is to maintain the necessary dissolved oxygen concentrations. Anti-foam controller is to control the foam of formations, and also level controller to control the level of working volume of the fermentation fluid. Next equipment is a main fermenter, MF102. The controller that we use is a temperature controller. It is to maintain the temperature of medium in the main fermenter at desired temperature at 28 degrees Celsius. For pH controller, it is to maintain the pH of a medium of Aspergillus niger, which is our bacteria, at desired pH, which is around 5.5. For dissolved oxygen controller, it is to control the dissolved oxygen in the process fluid. And then anti-foam controller, it is to control the foam of formation. Next equipment is a storage tank, which is T101. The controller that we use is a level controller and also flow controller. It is to maintain the level of glucose storage tank and also to control the flow rate of the glucose based on a level controller. And then the reactor R102. The controller is temperature, flow and also level controller. It is to maintain the temperature in the reactor at T equal to 37 degrees Celsius and also to control the flow rate of the inlet stream and also to maintain the level in the reactor. For centrifuge C101, the controller that we use is a level controller. It is to maintain the level in the reactor. For dryer ST101, the temperature controller is to control the outlet temperature in the dryer at desired range. And lastly, the cooler is a temperature controller, which is to control the outlet temperature within the range.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif bin Zakaria, and now I will continue our presentation for the process safety part. So in our production of gluconic acid, we are following the major act, which are OSHA, Occupational Safety and Health, 1994, Act 514. Next is Environmental Quality Act, 1974. And we also follow the Fisheries and Machinery Act, 1967, Act 139. For the HARAC analysis, in our production plant, the hazard that can occur is the explosion from the reactor due to the over temperature. The risk level is high, so we can control the risk by install the high temperature alarm and also the emergency response plan. Next is oxygen pipe inlet that can cause the fire due to the ignite of fire at the lower temperature. So it also have a high risk level. So we can also control the risk by install the high temperature alarm and also the emergency response plan. And next is the addition of ammonia in the seed fermenter, which can cause the physical injury. The risk level is medium, so we can schedule inspection and maintenance for the equipment. Next is storage of sulfuric acid that can cause the physical injury due to the overflow. So we can control by schedule inspection and maintenance of the equipment. Next, for the pumping of sulfuric acid, that also can cause the physical injury. So we can also schedule inspection of maintenance of the equipment. And lastly, when handling our main product, which is the gluconic acid, that also can cause the physical injury due to the leakage or overflow. So we can also control the risk by scheduling the inspection and maintenance of the equipment. Thank you.
From the first table, we can see that our plant is modified in year 2021 until 2023, and our plant design life is 20 years. The capacity productions increases on 2023 onwards. From the second table, for the manufacturing cost that we obtain is 37.61 million. For non-manufacturing cost is 29.86 million. For fixed capital investment is 67.47 million. For working capital, 10.12 million. Total capital investment, 83.81 million. Direct manufacturing cost is 13.77 million. Local taxes, 1.35 million. Property insurance, 0.67 million. And also fixed charge is 8.27 million. For plant overhead cost, which is 2.04 million. Cost of manufacturing is 22.03 million. For general expenses, cost obtained from our design project is 2.88 million, total production cost 24.91 million, and also depreciation is 7.81 million. Analysis for the first type, which is a return of investment, the value obtained is 0.174 per year. The value is higher than MER, thus the project is profitable. For the payback period, the value obtained is 4.71. It is less than PPREF, thus the project is considerable. Next is net return. The value obtained is 432.29 million. The value obtained is a positive value, thus the project is profitable. Okay, for net present value obtained is 247.79 million. The value is positive value, thus the project is also considerable. The discounted cash flow rate of return, DCFRR, I obtained is 0.178169. The interest rate is greater than MER. The project is attractive. The selling price for gluconic acid is 43 ringgit per kg with 17% of profit margin. It is considered a profitable price. The price of competing company is RM 80.86 per kg from Jinan Boss Chemical Industry CO Ltd from China.
Sensitivity analysis was conducted based on the gross profit of the plant. The parameter that affect the gross profit is the price of gluconic acid and also the production capacity. The table shows the effect of the gross profit when we increasing or decreasing the price of gluconic acid and also the production capacity. As we can see that the value of gross profit that we get is still positive. That means that the project is profitable.
Very good evening to my fellow lecturers and my fellow friends. My name is Tushan Raghunathan with a matrix number of GA04276, and this is my final year design project regarding production of gluconic acid from oil palm biomass. For the plant location, we have selected Pulau Manis, which is in Gambang, as the preferable site for consideration based on type of industry, raw material supply, facilities, and also labor availability. Not only that, based on the plant layout, we have also managed to find a separate section for the plant process and also to provide the emergency exit and assembly point for the workers. The direction of prevailing wind will also affect the plant layout. As for waste management, the total plant effluent has a temperature of 26 degrees Celsius, pH 5, a BOD value of 47,357, COD value of 135,306. After treatment, the final effluent that was released into the waters based on standard B was 46.62 for BOD, whereas the chemical oxygen demand was 133.19. The total suspended solid was only 73.78. Based on this process flow diagram of the wastewater treatment plant, the effluent from the plant first enters the equalization tank, and then it enters the primary clarifier, and it will then enter the secondary clarifier for further treatment. The sludge is then removed through filter press to Pusat Quality Alam or sold as fertilizer. Thank you.
So as for the conclusion, our plant is producing the gluconic acid, which acts as the antimicrobial agent and hand sanitizer, and also as a component for reaction with chlorhexidine to form the chlorhexidine gluconate. Our plant capacity is 50 kiloton per year. Our plant location is at Gambang, Pahang. We are using the dilute sulfuric acid, Aspergillus niger, oil palm from biomass, and also water as our raw material to produce the gluconic acid. So after doing the economic potential until level 4, we found out that our plant is production is profitable. And lastly, the concentration of COD and BOD in our plant is reduced by doing the wastewater treatment plant. So that's all from us. Thank you.